In this video, we're going to show you how you can combine RTC or real-time counter functionality with periodic interrupt timer functionality using the PLIB. We'll also measure power consumption using the PLIB data visualizer and the power debugger. So at the end of this application, we're going to have current, voltage, and power. Every 4 seconds, we wake from sleep and toggle a LED every 50 milliseconds and then go to sleep again. The video will give you an overview, but just remember to always check the API reference for the most up-to-date version of the use cases. My starting point happens to be an empty MCC Melody Project for the AVR 128DB48. But any AVR MCU supported in Melody should work just as well. We are also using the power measurement described in the Curiosity Nano user guide. So we're going to be looking at a use case of sleeping, then waking, and actually measuring power consumption of an application. So we're going to add a couple of modules to our project, RTC and sleep control. Set up the RTC for a 1 second overflow interrupt. We'll set up the periodic interrupt timer for a 4 second periodic interrupt. Then for sleep, we'll set it to power down mode and toggle a LED in between. So adding 2 components, a timer, which is our RTC, under system, sleep control. It's a non-default configuration option of system. So RTC, we wanted a 1 second period, and we're going to, the overflow interrupt is enabled by default. And on the PLIB, we want to enable that. And we want 4 seconds. The maths is a little bit more difficult with 32K, so we'll just make it a 1 kilohertz clock. You see that the period stays the same there. And here we can go for a RTC divided by 496. And now we're going to enable the periodic interrupt timer. Note this interrupt manager hint about enabling global interrupts. In sleep control, enable, and we can set this to power down. Looking in the data sheet, under sleep control, one can find a table here showing which peripherals can work in different power modes, and that the RTC is one of the few peripherals which can work in power down mode. There's a note here that in power down mode only the periodic interrupt timer functionality is available, and that's fine for us because we are using the PLIB to wake the MCU. So kit window, schematics to find our LED. So it's PB3, and this happens to be a debug GPIO. You'll select whatever LED you want to use on whatever board you might be using. So PB3, pins, LED. That is our configuration complete. Generate code. Now we'll come back to the API reference to consult the code snippets. So besides the default, we have sleep and delay. Then we have a flag about going to sleep or not. And this flag is set to false with the periodic interrupt timer. So the periodic interrupt timer wakes the MCU, and the RTC overflow puts the MCU to sleep. Then in main, we just register these 2 callbacks, and if we're going to sleep, we set our LED high to turn it off. MCU goes to sleep, and when we're awake, we're toggling a LED with a delay so that we can see a higher power consumption when we're awake compared to when we're asleep. So let's program. Open the data visualizer. We can turn on DJI for both the kit and the power debugger. So we just want to take the power, display raw, and it brings in current, power, and voltage. So maybe we want to switch these around a bit. So current times voltage equals power. So let's make our power red, and we'll add a plot of our debug IO. And here our application is working as expected. We see our debug IO toggling. If we pause, we can add some cursors. So you can see that we're awake for basically a second, and that every 4 seconds we wake up.